Hey, it's Mr. Redstone, and in this video we're going to be solving some multi-step equations. Now I'm starting off with two warm-ups here that look pretty straightforward, but there's more hiding under the surface than you might think. In the first case, x plus 2 is x plus 2. We got variables on both sides, so you might want to subtract x from each. You end up with 2 is 2. Does that mean your answer is 2? Well, if you substitute it in, it does make the equation true. Well, if you subtract 2 from each side, you end up with 0 equals 0. And if you substituted 0 in, it would make the left and right hand side equal. So what does this mean? I think the biggest tell is just looking at the question as written. A number plus 2 is a number plus 2. If you were to choose a value for x and substitute it in, the left and the right hand side are always going to be equal because it's the same expression on each side of the equal sign. This means that x can be any real number. There are infinite solutions. And when you have a case where it doesn't matter what the value of your variable is and it makes the equation true, we call that an identity. So in the next question, x equals x plus 1. Think of it, a number is a number plus 1. If you subtracted x from each side, you would end up with 0 is 1. Now, I can tell you that 0 and 1 are spelled and pronounced very differently. They're not equal. What does that mean? Well, think of it this way. If you take a number and add 1 to it, are those two values ever going to be the same? Of course not. This means there is no value of x that satisfies the equation. There's no solution. You could try any number, positive, negative, fraction. It's not going to make it true. So when you end up with one of these special cases, be sure to interpret the result. Don't just leave an answer as 2 equals 7 or 0 equals 0. Make sure you tell the reader what that means. So as we do these next few examples, some of these special cases will creep in. And to solve them, we're going to use that acronym I talked about in a previous video, DCI, standing for distribute, combine your like terms, and then use inverse operations. In the first example, I see parentheses on each side, so it looks like we're going to have to distribute and go from there. So the left, 15 groups of 1 plus 2g, and on the right, 3 groups of 3 plus 10g. I'm going to get 15 plus 30g, and on the right, I get 9 plus 30g. Well, you got variables on both sides, so let's get rid of one. We use the inverse operation of subtraction. Subtract 30g from each side to get 15 equals 9. Well, 15 and 9 are not equal, so please don't leave them as an equal sign. Make it not equal to. And the way we interpret this is there is no real solution for g. Wouldn't matter what you chose, the left and the right will never be equal. For the next question, just to erase and give myself some more room, it looks like we're going to have to distribute and combine some like terms here on the left. But we start by distributing. 6 groups of 3h plus 2 is 18h plus 12, plus 4h equals 12. Already I can see something interesting is going to happen here by those 12s. We combine our like terms. 18h plus 4h is 22h, plus 12 is 12. We use inverse operations to get rid of that add 12. And we end up with 22 times h is 0. Don't be tempted to think that that means no solution. What it means is your answer is 0. Because if we were to divide both sides by 22, you get h is 0. Doesn't mean no solutions. It means if you plugged in 0, the left and right hand side would be equal. Next up, it looks like we've got some distribution and then some combining like terms on the right. On the right-hand side, be careful. We don't do the 4 plus 2 first. Order of operations says we would have done that bracket, 3 plus 10j. Since we can't do that, they're on like terms, we would multiply by 2, and then we would add the 4. So when we do that, we get 10 plus 20, oops, I had a j and a g mix up. There we go. On the left-hand side, we have 10 plus 20j. On the right, we have 10 plus 20j. And immediately we can stop because the expression on the left is the exact same expression as what's written on the right. That's the definition of an identity or a case with infinite solutions. It doesn't matter what value of the variable you pick, the left side and the right-hand side will always be the same. I wait for myself to catch up to myself. Here we go, next question. Looks like we've got some distribution to do. Two groups of negative 4k minus 13. Well, that'll be negative 8k minus 26. So I've got variables on both sides. As a personal preference, I like to get rid of the smaller quantity. So to get rid of negative 8k, I add 8k. Now if you wanted to get rid of the 12k, you could. You get the same answer. So 20k plus 40 equals negative 26. You might be tempted to think at this point that there's no solution, but it just means your answer is going to have a decimal or a fraction in it, and that's fine. 20k is negative 66. Divide both sides by 20 to get negative 3.3 or negative 3 3/10. And that's it. So now I'm going to throw a couple of word problems at you. First one, the perimeter of a rectangle is 64 feet. What's the value of x? Well, at this point of your career, I'm assuming you can find the perimeter of a rectangle. It's 2 widths plus 2 lengths. So that's what we're going to do. We've got 2 groups of 3x plus 7 and 2 groups of 2x plus 10. And the perimeter was given in the question as 64 feet. So what we're going to have to do is distribute, combine our like terms, and then use our inverse operations. 6x plus 14 plus 4x plus 20 will equal 64. Some like terms on the left. We got a 6x and a 4x, a 14 and a 20. We put those together to get 10x plus 34 equals 64. And this is just a two-step equation at this point. Subtract 34 from each side to get 10x is 30, or x equals 3. If you wanted to substitute this in, replace all your x's with a 3, you would see that the perimeter does indeed equal 64. So for these next 2 examples, and they'll conclude the video, this is not the only way you can do them. I want you to realize that. So for what value of a would the equation have multiple solutions? Well, if it's got multiple solutions, it means we're looking for an identity here. So I'm going to start by distribution. A groups of 2x plus 3 would be 2ax plus 3a. And on the right-hand side, we can combine like terms to get 8x plus 12. If we have multiple solutions, it means the coefficient in front of the variable on each side has to be the same, and the constant has to be the same. So 2ax and 8x will have to be the same. So let's set them equal and solve for a. 2ax equals 8x, or divide both sides by 2 to get ax equals 4x. So just by looking at the setup of these 2 expressions, you know that a is going to be 4. And if I substituted that back into the earlier step, 3 times a, I get 3 times 4 is 12. So 4 groups of 2x plus 3 is 9x plus 12 minus x, or 8x plus 12 equals 8x plus 12. When a is equal to 4, you get an identity, and you get multiple solutions. So for the final example, what I'm going to be looking for is a case when we want no solutions. 3 groups of 3x plus 5 equals 9x plus b. What value of b would give us no solution? So what we're going to end up here is the case where we have the same value of a coefficient on both sides of the equal sign, but our constants are going to be different. So we have 9x plus 15 equals 9x plus b. If there are no solutions, we need these two values that I've highlighted to be different. That means anything besides 15 would work. So use the symbol not equal to. And that's it. Thanks for watching. I'll see you on the next one. Bye for now.